Imagine a computer that can solve problems in seconds that would take today's fastest supercomputers thousands of years. This is not science fiction, this is quantum computing. In this video, we will understand what quantum computing is from a physicist perspective without unnecessary complexity. Before we understand quantum computing, let us first understand what computing actually means. A computer is simply a machine that processes information. In classical computers, information is stored in the form of bits. A bit can take only two values, 0 or 1. Everything you see, videos, images, text, is ultimately represented using these zeros and ones. Limitations of classical computing. Now, here is the problem. As problems become more complex, like simulating molecules, optimizing systems, or breaking encryption, classical computers struggle because they process possibilities one by one or at best in limited parallel ways. This is where quantum computing comes into the picture. Quantum computing is a new type of computation that uses the principle of quantum mechanics. Instead of bits, quantum computers use something called qubits. A qubit is fundamentally different from a classical bit. A classical bit is either 0 or 1, but a qubit can be 0, 1 or both at the same time. This property is called superposition. Mathematically, we represent a qubit as ket psi equals to alpha ket 0 plus beta ket 1. Here, alpha and beta are complex numbers and their squares give probabilities. This means a quantum computer can explore many possibilities simultaneously. There is another powerful concept called entanglement. When two qubits are entangled, the state of one instantly affects the other, no matter how far apart they are. This creates strong correlations that classical systems cannot replicate. Because of superposition and entanglement, quantum computers can process information in fundamentally different ways. This leads to powerful algorithms like Grover's algorithm for fast search, Shor's algorithm for factoring large numbers. These are not just faster, they are fundamentally different. But let me be very clear, quantum computers are still in early stage. They are noisy, unstable, and are not yet ready to replace classical computers. This era is called the NISQ era, noisy intermediate scale quantum computing. Quantum computing has potential applications in drug discovery, material science, cryptography, optimization problems, artificial intelligence. In this course, we will go step by step from basic physics to real quantum algorithms and even quantum machine learning. If you are serious about learning quantum computing, this series will guide you from beginner to advanced level. In the next video, we will understand the difference between classical bits and quantum bits in depth. See you in the next video.